Video, I'm going to be working some multiple choice no calculator practice problems. So we're going to start off with y equals cosine 2x, dy dx equals, okay, the derivative of cosine of 2x. And, okay, so this is one of those outside and inside situations. They don't have parentheses on it, but it's like cosine of 2x. So, to take it back to the way we did it when we first learned about the chain rule, the outside is cosine of the thing, and inside is 2x. We take the derivative of outside and the derivative of inside, and then we multiply them, because that's the idea with the chain rules, you're multiplying derivatives. So it's going to be 2 times negative sine of something, so negative 2 sine of, and the inside stays the same, so that would be 2x. Okay, and then we're going to see, okay, that's going to be, where is it? Oh, that's just answer choice A. All right, number 2. Here we've got an integral and it's a product. And in calculus AB, we don't have a product rule for antiderivatives. So we're going to need to do something else, okay? We would prefer to just do some algebra, but we don't want to multiply x to the 3 minus 1 out 10 times. We don't want to do that. That would be crazy. We'd have to use Pascal's triangle, and then our answer would probably not even look anything like the answer choices anyway. So it's going to be something else. And in AB, there's really not that much else to use substitution. So what we're going to need to do is think about what is the derivative of something else. And x squared is close to the derivative of x to the 3 minus 1. So I'm going to look at that and say, okay, maybe I can take the antiderivative of u to the 10. Okay, so let u equal x to the 3 minus 1. Okay, so that du is, we take the derivative and multiply by dx. We can do that in one step now. We've done enough of these. Okay, but we don't have exactly 3x squared dx. We have x squared dx. Okay, and so that's going to be 1/3 of du. And because when I make the substitution, I need to get rid of all of the x's and convert them all into u's. So I'm going to go over here and say, okay, well, the x squared and dx is turning into a 1/3 and a du. We're still anti-differentiating. Something to the 10th power, and we're calling that u. Okay, so now I'm going to take my antiderivative, add 1 to the power, divide by the new power. And that's where I'm going to get 1/33 times u to the 11. Okay, there's no x to the 3rd needing to hang around there. It's going to be answer choice D. Okay, now number 3, here we've got a limit as x approaches infinity. And we see that, right there, x is approaching infinity. We want to think about kind of end behavior, just relative growth rates. We can also kind of attack this problem the way that we did in AP Pre-Cal, and that's what I'm going to do. And because I really like that strategy. It's, not, maybe the most mathematically robust thing to do, but it is legitimate. And, if you prove the rule in general, then you could use this trick pretty freely, I think. And so what we're going to do is we're going to take the highest thing on top and bottom, and we're going to divide them. Okay, so it's going to be the square root of 9x to the 4 over 4x to the 2. And as x approaches positive infinity, the square root of 9x to the 4 is going to be positive 3x to the 2. Okay, so that's 3x to the 2 over 4x to the 2, and that's going to equal 3/4 as long as x is not 0, but we're talking about as x approaches infinity. And what happens is the original fraction has the same end behavior as this fraction that I've reduced off in red, and so that's to say it's going to approach y equals 3/4. Okay, now over here we've got another derivative question, and this is going to be chain rule and quotient rule, so we need to think about the outside and the inside. So give us lots of room. So on the outside we have the thing taken to the 5th power, and on the inside it's this fraction. And so we take the derivative of the outside and the derivative of the inside. Okay, and this is going to be the quotient rule. Remember, that starts at the bottom. It's the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Now this is going to require some simplification, because if you look at the answer choices, they all look quite a bit simpler than what I'm looking at here. Okay, so that's going to be 1 times x plus 1, that's x plus 1. And then minus an x. Okay, and now I'm starting to see what's happening here. The x minus the x leaves me with just a 1 there. And all right, 1 over x plus 1 squared. Okay, and now I'm going to multiply outside prime and inside prime, and that. And that's going to give me 5 times the original inside to the 4th power. Okay, so that's x over x plus 1. Then multiplied by the derivative of the inside, which is 1 over 2 more powers of x plus 1. And then I'm seeing, okay, that's where I'm going to get a total of 6 powers of x plus 1 in the denominator, because 4 from the middle term and 2 more from the last one. So I've kind of got it down to d and e. And then I'm looking for 5x to the 4 in the numerator. I don't know where that 2x plus 1 would come from, but I don't really want to know. That's some kind of mistake that we didn't make. Okay, now number 5. Water is flowing into a tank at the rate r of t, where r is measured in gallons per minute and t is measured in minutes. Okay, it starts with 15 gallons of water at time t equals 0. Okay, we're going to use a trapezoidal sum with the intervals indicated by the table to get the number of gallons in the tank at t equals 9. Okay, so this is going to be the ending value, so maybe the thing we're looking for is going to equal, I'm not even going to get a name, this is a multiple choice question, it's the starting value plus the integral of the rate n, right? So that's r of t. And we're going to start at time 0, and we're interested at time 9, and that works really well with our table. And so that's going to be 15 plus, and now we're going to do trapezoidal sum. So we've got a width of 4 minutes for our first one, and we're going to average the heights. So 6 and 9, okay, halfway in between 6 and 9 would be, if you're not sure that it's 7.5, what you do is 6 plus 9 divided by 2. I worked this one this week, so I remember they said way out if you're concerned about the arithmetic. Okay, the second one has a width of 3, 4 to 7, and we average 6 and 4, and I think you can do that one mentally, that's 5. Okay, then 7 and 9, that's a width of 2. Height is going to be halfway between 3 and 4, and there we go. Now, that's going to be 15 plus, I'll deal with that thing later, that's another 15. 2 times 3.5 is going to be 7. Okay, now what we're going to have to do is maybe do a little bit of simplification. Well, I could multiply the 4 and the 1/2 together and say that's 2 times 6 plus 9 is 15. Okay, so I've got 2 times 15 is 30. 2 more 15s is another 30. That's 67. Okay, now this one's slope of the tangent line. That means we're going to take the derivative. So I need dy dx. Okay, this one's also an outside and an inside. We know that the chain rule is a big deal in AP calculus. Okay, so on the outside I've got log inside 1 minus x. Derivative of log of a thing is 1 over that thing times the derivative of that thing. The derivative of 1 minus x is going to be -1. So outside prime times inside prime equals 1 over 1 minus x multiplied by -1. Okay, so I call that -1 over 1 minus x, and then I'm going to plug in x equals -1. And I'm going to get -1 over 1 minus -1, and that's going to be -1/2. All right. Which of the following pairs of functions is the limit as x approaches infinity of f divided by g infinite? Okay, so that would be infinite would be if f was growing faster than g. Or potentially if x was approaching infinity and g was going towards 0, but I don't, that's not happening in any of the answer choices. So I want kind of like f grows faster than g. I would love for f to be an exponential function and g to be a polynomial. Oh, there it is. See, yeah, there we go. Don't make it too hard on yourself. Yeah, D has got an issue because they're the biggest thing is both exponential. All right. Then This one, okay, you've got a fraction, and there's not anything we can do with it algebraically. And this is calculus AB, so that's kind of all we've got is algebra and u substitution. So we must need to do a u substitution. And I'm going to zoom in a little bit. I'm going to take my time. The thing, okay, if you just see that we're going to let u equal x squared minus 9, you start with that and you go from there. But if you don't, you can rewrite to use the powers because you know that we're going to eventually want to use the power rule on something like this. I don't see trig or log or exponential or anything. X equals 0, x equals 4 of x times x squared plus 9 to the negative 1/2 power dx. Okay, up to you. If you already see that the inside of the composition of functions whose derivative is appearing on the outside with multiplication is x squared plus 9, go for it. If not, then you might want to rewrite it for a second. So du is 2x dx. That's not what I have. I have x dx. So I'm going to divide both sides by 2. Okay, so I've got 1/2 and a du. I'm still integrating, but now I'm taking u to the negative 1/2. And now what's left for me is to convert the bounds of integration. Okay, I started with x values, but I've converted this integral to u, so I need to convert those x coordinates, x equals 0, to u coordinates, so that's u equals 0 squared plus 9, and then when x equals 4, u will equal 16 plus 9, which is 25. Okay, and I've got my integral fully converted, and now my job is to anti-differentiate. Okay, antiderivative of u to the negative 1/2, add 1 to the power, divide by the new power. Okay, then I'm going to let u run from 9 to 25. And, I can factor out the 2 and multiply by the 1/2. And so that's going to be u to the 1/2 from 9 to 25. Oh, that's going to be pretty nice on a computation level. And so I'm going to get 5 minus 3, and I'll get answer choice D. Here it's asking, when is f decreasing? Okay, and we know that f is decreasing when its first derivative is negative. So we're going to need to make a sign chart. Because I don't know about you, but I don't just know what the graph of negative 2x over 1 plus x squared looks like. Okay, so what I need to do is think about kind of the important points on this fraction would be x values where the fraction could change signs. So that would be zeros in the numerator and zeros in the denominator. But really the only zero I see on this thing is going to be x equals 0 because the denominator can never equal 0. So I'm just going to put 0 there and do a test value on either side. So I'm going to do f prime of 1. And that's negative, and then maybe f prime of negative 1. So negative 2 times negative 1 would be 2 over the denominators. It's something squared, so that's going to be a positive number. And so, okay, decreasing is just going to be when x is greater than 0. Okay, so answer choice A. Okay, antiderivative of e to the x plus e. Oh, well, this is great. So we know the antiderivative of e to the x is e to the x, so I'm going to get rid of this one and that one. And the antiderivative of e, okay, that's kind of the potentially tricky part. Remember, e is just a real number. And if it was e to the x plus 5, the antiderivative would be e to the x plus 5x plus c. So I'm going to choose answer choice E, not overthink this, I'm going to move on. And it was a whole page to work that problem, though. That was maybe a little misleading. Okay, so this is the function f, which could be f prime. Okay, and so there's a number of ways that you could do this one. You could kind of maybe go off the extrema and just say, okay, well, this is a minimum, so I need the derivative going from negative to positive, so that's definitely not that. Could be b, negative to positive, no. Maybe D, I don't know what's going on there, maybe E, I don't know, okay. So I've got a 2 of 5 eliminated, and then you could use the maximum, but what I actually would recommend is saying, wait, okay, this is the only section where f is increasing. I would say go off the increase-decrease behavior. Okay, so it's increasing in the middle, which means that f prime is only positive in the middle, and that's going to be answer choice B. Okay, D, the sign is changing. Well, actually, what's going on there? Okay, why not E? let's think about E, because E is right there. It's kind of appealing. It's positive throughout the middle section of the graph. Okay, so what's happening here is that would be saying f prime of 0 equals 0. And that's not going to be true, because if we go back and look at f of x, f is increasing at x equals 0, so we know that f prime of 0 has to be a positive number, and that's why I'm sticking with B. Right. If C is between 0 and 1, what is the area of the region enclosed by the graphs of y equals 0? That's the x-axis. Y equals 1 over x. Okay, we know that. It's about like that. X equals C and x equals 1. Okay, so I'm going to put x equals 1 right there. Best ever, but okay. And then x equals C. It's between 0 and 1, so I'm just going to put it right there. Okay, and there I've got the region. Okay, so this looks to me like it's just going to be the integral of top minus bottom, 1 over x minus 0. Okay, so that's the height of the rectangle. We're integrating from x equals c to x equals 1. Okay, and anti-differentiate, plug in the bounds, and subtract. So log of the absolute value of 1 minus the log of the absolute value of c. I know that 1 and c are both positive numbers, so I can do that. Natural log of 1 is the exponent I would put on e to get 1. Okay, and that's going to give me a negative natural log of c. Okay, so I can start eliminating some answer choices. Okay, that's not right. And okay, so I'm down to a and b. It's like, oh, which one is it? And I need to apply a log property here. So negative 1 times the natural log of c can be rewritten as natural log of c to the negative 1 power. And that's where I'm going to choose answer choice B. Okay, that's, this is a kind of an older problem set, and that's not something that you would need to do at this point in AP Calculus. That's something that they're testing in AP Pre-Cal, and also, you could get all the way down to the second to last line in black and have done all the calculus right and forget your pre-cal property and not be able to get the problem right. And we don't want that. It's a calculus test, not an algebra test. So, over here, to that end, okay, you need to know the derivative of arctangent x for AP Calculus. You need to know the derivative of all the trig functions, all the arctrig functions, and all the exponential functions as well, like 5 to the x. Okay, so the derivative of arctangent x is 1 over 1 plus x squared. And okay, well, I'm just going to think about that as 2x to the positive 1/2 power. And so I'm going to multiply the 1/2 by the 2 and get 1x to the subtract 1 from the power. So that would be answer choice E. And that's one of those where if we just know our formulas, that's going to really speed up the process. Okay, we don't have to sit a bunch of time thinking about that when we could be thinking about one that's genuinely challenging. Okay, so f is a solution to the differential equation dy dx equals e to the x squared with the initial condition f of 0 equals 2. Okay, so I solved this one. Somebody asked me about this one in class, and I'll show you what I did in class right now, because the first thing I thought of was like, oh, well, they're asking for f of x, and they gave me f of 0, and they gave me a derivative, so I'm going to say, okay, I told you that f of b equals f of a, starting value, plus the integral from a to b of f prime of x dx. And what we could do is we could go in and just kind of like substitute on stuff like, okay, what did they give me? They gave me f of 0 equals 2. So I'm going to say, okay, so f of 0, okay, so I'll put a 0 there. And what we're really interested in, if I look at the answer choices right there, we want f of x, so I'm going to replace b with x, so we can get a formula for f of x. And f prime of x, that's the same as dy dx. And so, I'm getting in here and I'm seeing it's got to be f of 0, which is 2, plus the integral of e to the x squared dx. This actually doesn't make any sense. So it's like, oh yeah, I can say, use a dummy variable and say, okay, I've got answer choice D. But I don't know that that's actually the most natural way for a first-time calculus student to approach this problem. I think what you might do is look to take the derivative of the answer choices or maybe start off with f of 0 equals 2 Okay, so I can get rid of answer choice B because f of 0 equals 0. Answer choice C I would get rid of on that level 2 because it'd be the integral from 1 to 0 of a positive function, so it's got to be a negative number, not 2. And E, I feel the same way. It's going to be less than 2 because the integral from 2 to 0 of e to the t squared, I don't know what that is. I don't want to calculate it, but I know it's going to be a negative number because it's integrating backwards on a positive function. Okay, so I've got it down to that. And now I'm going to take the derivative of answer choices. So like for A, I'm going to take f prime of x and get, 0 plus e to the x squared times 2x for the chain rule. Well, that's not e to the x squared, so that's a problem. And then for answer choice D, I can say, okay, the f prime of x, the derivative of 2 is 0 plus, then I would throw that in for t, e to the x squared, and the derivative of x is 1, so I'm good there. Okay, that is another reason why answer choice D is the right one there. That's a good question. I don't remember having seen that one in the past. Okay, so a function f gives the rate of evaporation in liters per hour from a pond where t is measured in hours since noon. Okay, so if I integrate the rate function, which I'm seeing right here, if I take the integral of the rate, I'm going to get the total. Okay, so it's the total amount of water that evaporated. Okay. And it's going to be from 4 to 10. Yeah, not during the first 10 hours after 12 noon, between 4 p.m. and 10 p.m. because it's between the 4th hour and the 10th hour. Okay. Don't read too hard at the other ones and try to talk yourself out of the right answer. It's like, if you integrate the rate function, you're going to get a total. All right, so f prime equals 3x to the 4 minus 12x to the 3, point of inflection. Okay, so what you need to know is that a point of inflection is a sign change on f double prime, not a 0. Okay, I had some people on a recent test this year, it's been a while since we talked about point of inflection, give me the reason f double prime equals 0. That is not, has never been, and will never be a valid reason for a point of inflection. So just like, I don't know why that was in your vocabulary in the first place. It never should have been, right? F double prime equals 0 is really never a valid reason for anything, besides maybe looking for a critical point of f prime. But I've never seen that problem type before. So f double prime is going to be 12x to the 3 minus 36x to the 2. There's going to be a fake inflection point here, so I'm going to factor out the x to the 2. And, if you wanted, whoops, that's not how this one works. You could also factor out the 12, and have an x minus 3. And then, okay, I know what this looks like, a third-degree polynomial with a positive leading coefficient. Now, you could make a sign chart for this as well, but I can see what's going to happen. It's got zeros at x equals 0 and x equals 3. At x equals 0, it's a double root, so the curve's going to bounce, and then at x equals 3, it will pass through confidently because it's a single root. And I'm seeing that's the only sign change on f double prime, so it's going to be x equals 3 only. Okay, next we've got an average value function. And I find it interesting that the function they're going to have us find the average value of is 1 over x again, because we just did an integral of 1 over x. But okay, you need to remember that the average value, that's a formula we need to know. We add up all the function values, so the integral from 4 to 6 of f of x dx, and then we divide by the width of that interval, 1 over 6 minus 4. So that's going to be 1/2 of the integral from 4 to 6 of natural log x. This one's going to also apply a log property, okay? So that happened twice in one problem set. That's obviously unrealistic. That's not going to be happening to you anytime soon. Wait. No. I'm way ahead of myself. F of x is 1 over x. The antiderivative is natural log of the absolute value of x. There we go. So 1/2 of natural log 6 minus natural log 4, and that's probably what the correct answer would look like, today. But, at this point when this exam happened, you needed to be able to apply the log property and say that was natural log of 6 divided by 4. Okay, that's 3/2, and that's where we are over here. I don't totally understand why they didn't say that it was the natural log of the square root of 3/2, right? Like, because they're going to apply one log property, why not apply the other one? Don't totally understand that, but it's okay. It doesn't really happen anymore. Okay, now we're looking at this graph, and we've got a rectangle, and x is greater than or equal to 3, and where is the area a maximum? Okay, now, idea is get a formula for area and take the derivative and set it equal to 0 and solve for x. Okay, so what we need is the area of this rectangle. So I'm going to make a little replica off to the side. And the base of the rectangle, the width of the rectangle, is going to be right minus left is x minus 3. The height of the rectangle is going to be top minus bottom. Okay, we can see one of the points along the top is going to be y equals 1 over x squared, and the bottom is the x-axis, which is y equals 0, so got that. And so multiply base times height. Okay, now, I would actually recommend writing this as x minus 3 over x squared. But if you want to do the product rule and solve that way, that's totally an option. Like that's something you could do. I'm interested in a prime equaling 0 though, so I'm going to need a prime of x, and I'm going to kind of get in and look a little closer there. So a prime of x, and use the quotient rule, bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. X squared. I'm going to distribute and be careful with parentheses. Okay, so minus, that's going to be a 2x squared minus 6x multiplied by x to the 4. And I'm going to subtract x squared minus 2x squared is a negative x squared. And the negative of 6x would be positive 6x. I can factor the top. I can see, okay, well, I know that x needs to be greater than or equal to 3, so the only 0 of a prime is going to be x equals 6, and I have faith that it's going to be that. Okay, now I also know that it's going to be that because I can think about the extremes of this situation. X is greater than or equal to 3. Okay, so if x is equal to 3, that's the rectangle. It has no area. It's just a stick. And then as x approaches infinity, like the farther out we go, the closer it's going to get to that. It's going to have no height. So that would have no area as well. So there's got to be some maximum there in the middle. And x equals 6 seems super believable. Okay, and I have evidence to believe that the derivative of 0, that's the only time the derivative of area equals 0 besides, some sort of weird situation happening at x equals 0. But we're not really interested in that case. So what are all values of x for which this integral is equal to 0? We'll just take this integral and set it equal to 0 and solve the equation. I think that's going to be the way to go. Okay, so antiderivative of t to the third from t equals x to t equals 2. And that's going to be equal to 0. And we're just going to have faith that this will work out. 1/4 of 2 to the 4th is 1/4 of 16. Minus 1/4 x to the 4th equals 0. Okay, so maybe I could just multiply both sides of the equation by 4 and get 16 minus x to the 4 equals 0. So 16 equals x to the 4. And, okay, that's x equals 2. But then I look at the answer choices, it's like, oh, x equals negative 2 also is going to work for that. I've got that. I'm seeing that answer choice of E that offers x equals 0, but the integral from 0 to 2 of t cubed, I mean, you know what t cubed looks like. Yeah. It's like that, and if 2's over here, okay, there's going to be a positive amount of area. That's not going to be an integral that equals 0. All right, so, yeah, I've selected my answer choice. I'm moving on. Okay. h of x is the integral from pi over 4 to x of sine squared t dt. And don't worry, this is not an antiderivative you need to know. They're asking for an equation for the line tangent to the graph of h at the point where x equals pi over 4. And you might be like, oh, well, to get the point, I'm going to need to run the integral. And yeah, you definitely will, but okay, so to get the point, I'm going to do h of pi over 4 equals the integral from pi over 4 to x is pi over 4, and then you say, okay, I actually don't need an antiderivative for that because I know whatever it is. I'm going to plug in the same value for top and bottom, and there's going to be no difference in the antiderivative there. It's out there, it exists. Sine squared t is continuous, so, at the very least, you could approximate the antiderivative with a polynomial, if you stuck with me and took the BC component of the class. But we don't need to know that, so we just know that point gives us a y-coordinate of 0. So my point is pi over 4 and 0. Then the slope, I need h prime of x, and that's where I'm going to throw in x wherever I see t in the integrand. Okay, so that's sine squared x, and the derivative of x is 1, so that's h prime of x. Plug in pi over 4. Remember, sine squared is we take sine and then we square it. Okay. Maybe it's been a while since you've made a trig diagram, but it never hurts to make one. Okay, this is pi over 4. It's a 45, 45, 90 triangle, and that's where both of these are root 2 over 2. So sine is going to be root 2 over 2 divided by 1. And that would be 2/4, so my slope is 1/2. Okay, so I'm looking for something with slope 1/2, and that's only going to be answer choice D, and that does make sense with the point slope form. Okay, so I'm ready to move on. Okay, which of the following must be true? Twice differentiable function f. Okay, so I'm going from -30 to -2 to 10 to 18. Okay, so we're looking for statements that must be true. So it definitely could be true that f is increasing the whole time and has no critical points, but I don't think that has to be true. F prime of x equals 8 for some x in the interval -1 to 5. Well, we could test that using the mean value theorem. Okay, we know f is twice differentiable, so it's going to be continuous and differentiable enough for us to apply the mean value theorem. So we're going to compute the average rate of change. It would be 18 minus -30 over 5 minus -1. Okay, so that's 48 over 6. And that does equal 8, and that must be true. Okay, I'll go through and explain why the other ones don't have to be true, but if you're convinced by that and this is the time to test, you should move on and then come back and read the other ones later. Like, I don't know, maybe mark this one for review or something. Okay, the next one, f prime of x greater than 0 for all values of x. This could be true, but this doesn't have to be true. It could go up from -30 to 0, down to -2, down a little bit more, and then back up to 10. We don't really know what's happening between these x values, so that's not going to be true. F double prime of x is always negative. I bet if we took the second differences on the table, that would be true, but that doesn't necessarily have to be the case because, because of the situation I just described. I think if I went from -30 to 0 to -2, then up to 10, that would require some sort of point of inflection in there somehow. No points of inflection, yeah, this I don't know that to be 100% true. So that's why it's going to be that answer. Okay, this one, oh yeah, I remember this one. I worked this one a couple of times last week. Okay, so a of t is 15 square root of t. And so because we're asking for the velocity, we're going to need to take an antiderivative, so we should probably use the power rule and write it like that. Okay, so I'm just going to go as if nothing is wrong. Velocity is an antiderivative of this, so 15 times add 1 to the power, divided by the new power. Okay, so 15 times 2/3 is 10 t to the 3/2 plus c. Then I go and I look for some sort of velocity that they're going to give me so I can find c, and I can't find it. And they're just giving me two positions. It's like, okay, that's kind of annoying. So what I'm going to need to do is take the antiderivative again, knowing that c is a constant. So I'm going to add 1 to the power, and divide by the new power. So that would be multiplying by 2/5. And c is a constant, so its antiderivative will be ct, and then I'll have some new constant, which I might call d. All right, so now I've got the position is 10 when t equals 0. So 10 equals, okay, 2/5 of 10 is 4. So it's 4 times 0 plus 0 c's plus d, so d equals 10. Okay, and then when t equals 1, the position's 20. Okay, so 4 times 1 plus c plus d ended up being 10. So 4 plus 10 plus c equals 20. That's going to give me c equals 6. And velocity at time 0, okay, so v of t is the 10t to the 3 halves plus c, which I determined was 6. So there, I'll get d. Okay, oh yeah, I remember this one. I really don't like this one, if I'm being totally honest. But, you know, it's okay. What we can do is we can definitely plug in x equals 0 and try to eliminate some answer choices. You know, just using the initial condition, and I need to get 1 back. But that is happening for sure. Yes on A, yes on B, no on C, because the natural log of 1 is 0. Yes on D, because that's 1 plus 0. And also yes on E. Okay, that wasn't super helpful, but it did help me eliminate an answer choice. I'm going to have to do separation of variables because I've got x and y in my derivative. So I'll divide both sides by y and multiply both sides by dx. Okay, anti-differentiate both sides, and then I go over here, and it's like, oh, whoa, what's going on here? So I'm going to need to do some u substitution. Okay, so the antiderivative of, okay, 2x dx becomes the du. I'm left with a 1 over u. That's going to be log absolute value of u. So, and then u was x squared plus 1 plus c. Okay, I don't know how I knew to do this, but when I was working this one in class, I was like, okay, I'm going to plug in 0, 1 now. I don't know why I wanted to do that, but y equals 1, x equals 0. Okay, so, and then I don't even need to know what natural log of 1 is to know that c needs to equal 0 in this case, because natural log equals natural log of 1, or natural log of 1 equals natural log of 1 plus c. That tells me c has to equal 0. Okay, then from there, I'm just going to, now being informed about what the value of c is, I'm just going to say this. And then I guess it's answer choice B. I really don't like this one because you could be right for the wrong reason on this one. It's like this one kind of implies an algebraic property that's not legitimate. So, what else to say? I do like this one though. This one's a related rate problem that's got quite a bit going on, a few different levels to work on. So sand is deposited onto a pile with a circular base. Okay, so I'm kind of envisioning like a cone. But now they're going to tell me the volume is given by v equals r to the 3 over 3. So that's kind of the first thing I know. Where r is the radius of the base in the feet. The circumference of the base is increasing at a constant rate of 5 pi feet per hour. Okay, so I must need the circumference formula so I can take the derivative of it. Okay, so the circumference of the circle that is the base, okay, that would be 2 pi times the radius. We do need to know that. Okay, circumference is equal to 8 pi feet, so we'll need to use that eventually, I'm sure. What is the rate of change of the volume of the pile in cubic feet per hour? So what is dv dt? Okay, so that's a lot of things to work with. I think what I'm going to do first is take the derivative of the circumference and say, okay, dc dt equals 2 pi times the derivative of r with respect to t would be dr dt. And I can plug in 5 pi, so that's what they told me was the value. And okay, 2 pi dr dt. Okay, that must mean that dr dt is 2.5. I'm going to take issue with the amount of space they gave you to work this problem, unless there's just something I'm totally missing on this. But it seems like I need all of this work that I'm going to be doing here. All right, so I've used the dc dt and the c, so I must need to use this fact that c equals 8 pi. Also, see what that shakes out. C equals 2 pi r, c equals 8 pi, that must mean that r equals 4. Okay, see what I'm going to use that for in a minute. I'm going to take the derivative of v, because that's going to give me my answer. So I'm going to take the derivative of this thing and say that the derivative of volume with respect to time is going to be, I'm going to take the derivative of r to the 3 over 3, and that would be r to the 2 times the derivative of the inside with respect to time. Okay, so r squared dr dt. Okay, and that makes sense because that's exactly the ingredients I've got. Okay, so it's going to be something squared times something else. Okay, so it's going to be r squared times dr dt. Okay, so 4 squared would be 16 times 2.5, and if you don't know that, you could do 16 times 5 halves and divide 8 times 5, that would be 40. All right, number 25. Okay, here's one that, I'm going to want you to solve one way, but you're probably going to want to solve another way. Okay, when you see the limit as h approaches 0, you should know that this is actually code for a derivative question. They're asking you to take the derivative of some function at some x value. So I think it's going to be at, but like seeing this is definitely an art form that I have not, figured out a great way to, show first-time calculus students how to do. So this is going to be the derivative of e to the negative 1 plus x at x equals 0. Because we're thinking about the limit as h approaches 0 of f of x plus h. Or, okay, so maybe I was wrong. Maybe it's negative 1 minus x. That would probably be, yeah, that's going to matter. Minus f of x divided by h. And so that might be why this method is somewhat unreliable. But anyway, I'm going to take the derivative of e to the negative 1 minus x, and that would be negative e to the negative 1 minus x with at x equals 0, and that's going to be negative e to the negative 1, so that would be answer choice B. You might want to solve this one using L'Hopital's rule because the numerator and the denominator are both approaching 0. So this would equal, and I'm going to take the derivative with respect to h, and so I'm going to end up doing the exact same thing, so negative e to the negative 1 minus h. The derivative of e to the negative 1 is the derivative of a constant, that's 0, divided by the derivative of h is 1, and that's going to be negative e to the negative 1 the same way. Okay, so it doesn't really matter. I don't care how you're doing it. If you do it with L'Hopital's rule and you understand how that works and you're good at taking derivatives, great. You're going to take a derivative on that thing either way. Okay, so that's what we're going to do there. Okay, this one, for what value of x does the instantaneous rate of change of f, that's f prime, equal the average rate of change of f on that interval, that's going to be f of 3 minus f of 1 divided by 3 minus 1. Okay, so what I'm going to do is I'm going to compute f of 3 minus f of 1 over 3 minus 1 first, because I think that's going to be a little bit more, computational. Okay, f of 3 is going to be 3 to the 3 is 27 plus 5 times 3 minus f of 1. Divide by 3 minus 1. Okay, now what we could do is say that's 27 minus 1 is 26 plus 10 is 36 divided by 2, 18. However you're going to get that, doesn't really matter. Really not important. F prime is going to equal 3x squared plus 5. And we want to set these two things equal. So 3x squared plus 5 equals 18. Okay, that's a unique equation. So I'm going to start solving at x. And because there's only one power of x, I can just solve directly and eventually take a square root. So, okay, 3x squared equals 13. Solve for x squared, 13 thirds. I see that's going to be answer choice B. Okay, and it's going to only be the positive square root of 13 thirds because it's only on the closed interval 1 to 3, right? We only want positive x's. Okay, so there we go. And I think I have faith that the square root of 13 thirds is between 1 and 3. Why would that be? 13 thirds is a little bit bigger than 2. I mean, it's a little bit bigger than 4, so the square root is going to be a little bit bigger than 2. That's what I was thinking. Okay, now 27. This derivative here, e to the xy, is definitely tricky. Okay, and I think what I would do is just remind you that on implicit differentiation, AP Calculus, they really like the derivative of x times y. And so I'm going to go over here off to the side and just remind you that when we're taking the derivative just of xy, that's something we need to be careful with. It's product rule, right? It's x times f of x. So if I'm taking the derivative with respect to x, I'll do x first. Its derivative is 1. Leave y the same. Then add, leaving x the same, taking the derivative of y with respect to x. Okay, so y plus x dy dx. Now, over here, when I go to take the derivative of both sides of this equation, I'm going to take the derivative of e to the xy, and the derivative of e to the thing is going to still be e to that same thing times the derivative of that thing. And that's where the y plus x dy dx is coming in. Okay, and then that's going to be minus the derivative of y squared is 2y dy dx equals the derivative of e minus 4. E minus 4 is just a number, so its derivative is 0. Okay, now I'm going to plug in x equals a half and y equals 2. So e to the 1 times y plus x dy dx minus 2y dy dx equals 0. Okay, I am not liking the way that this is looking, but what can I do here? I'm trying to think. I'm going to distribute the e. I'm going to definitely multiply both sides of this equation by 2 to get rid of the fraction. I'm not really sure what's happening here. 8 dy dx equals 0. All right, so I'm going to say, just push all the stuff with dy dx to the other side, I guess. 8 dy dx minus e dy dx. Factor out the dy dx. There's got to have been a better algebraic way to do this one. Okay, 4e divided by 8 minus e. There it is. Okay, maybe I should have looked at the answer choices sooner and strategized once I saw the 4e, e, and negative 8. But yeah, I mean, that would have got me down to 2, and I probably could have figured it out from there, but okay, that's fine. It's number 27, so it definitely wasn't intended to be one of the easiest questions on the problem set. Okay, and here we have number 28, the last one. Okay, so g is f inverse of x, where g of 3 equals 1. Okay, so what that's saying is f inverse of 3 equals 1, and that is true. We can see that f of x equals 3 happens when x equals 1. Okay, so that was just them being polite and making our lives a little bit easier. I would not, like, especially like right after I show you how these problems work, I would have no hesitation not telling you that f inverse of 3 was 1 and still asking for f inverse prime of 3 like they're doing here. If they want g prime of 3, g is f inverse, so g prime is f inverse prime of 3. But remember, our formula is f inverse prime equals 1 over f prime of f inverse, where f inverse is just some x value. Okay, well, that's what I'm seeing here. That's that x equals 1. So let's see. Okay, that's 1 over f prime of 1. I'm going to need to take f prime of x in order to get f prime of 1. So that would be f prime of x equaling 3x squared plus 2x plus 1 plugging in x equals 1, getting 6. And so f inverse prime of 3 equals 1 over f prime of 1, which is 1/6. Okay. There we go. And that's all for the multiple choice no calculator section of this practice test. So that's going to be all for this video. Thanks for watching.